Cool, welcome everyone. Good morning. Wow, face-to-face. How about that? It's been a while. If you look under your seats, there's little cardboard masks with your initials on it. You put them on and make me feel at home, like I'm back doing remote again. I feel so out of practice, but hey, let's kick off. So today I want to talk to you about deploying cloud infrastructure using a tool called Pulumi. By way of introductions, my name's Shahid. I'm a principal platform architect at a company called Aura. We're based in New Zealand. I forgot to start my timer. Let me do that quickly. We're based in New Zealand. We have offices in the UK, US, and Australia as well. We're a SaaS provider of a retail crime intelligence platform. We're built entirely on Microsoft Azure PaaS. I'm an Azure MVP, and I have a background in software development. So I've been software developer for a scary number of years now, and in the last, coming up to about 10 years, doing a lot of cloud architecture as well. And it's my background, I think, is probably why Pulumi resonates with me and why I'm kind of quite passionate about talking about it. If you want to get in touch with me, LinkedIn, I've got my LinkedIn details there. Twitter, probably the best place, really. So what we're going to cover today, I want to talk about how we provision cloud infrastructure, some of the common approaches we have at the moment, talk about some of the limitations of those approaches, and then I'll really talk about Pulumi. So this is very much a kind of introduction level talk in terms of Pulumi. So if you know Pulumi quite well, may not be the talk for you, more than welcome to go and join another session if you like. So when we think about people's journey to cloud and provisioning infrastructure, the obvious and the first place most people start is the portal. And that makes a lot of sense. The portal gives you things like discoverability. So you know what you have available because you can see it in the portal. You see these resources available to you. And that's really quite key, especially when you're getting started. When it comes to provisioning the resources, the portal gives you wizards and it gives you options. It shows you what you can provision. It gives you drop-down boxes. Tells you whether you can have 2 CPUs or 4 or 6 CPUs, for example. And that's really important when you're getting started. And of course, one of the key things it does is it validates your inputs. But hopefully anyway, it tells you if you've picked something wrong before you've even got too far. And that's a really great way to get started. Now, of course, the problem with that is it's quite limited in what you can do. So you can't really be consistent in terms of repeating yourself. Now, I'm terrible at this. If I'm doing something in the portal, I will name it one way. The very next time I do it, I'll change the naming. I'm awful at it. I'm really bad. Sometimes the options you want are buried deep in submenus. Now, when you're first understanding a resource, that's great because it's there, it's available. But when you want to do something quickly, having to click 3 or 4 menus deep is a real pain. And of course, because it's you clicking a mouse on a screen, you really can't provision lots of resources very quickly. No matter how fast you can click, there's only one of you doing it, and that's quite limiting. And of course, to some extent, you have to resolve your dependencies yourself. So not a great example, but let's say you've got a web app and a database. You're probably going to provision the database first because you want the URL for the database to put in the connection string. So you've got to do that kind of resolution of the dependencies yourself. And because of these kinds of limitations, the concept of infrastructure as code has come about. So I'm not going to read this whole definition, but essentially what it says is there's machine-readable definition files you can give to the machine, and it will provision the resources for you. And we'll come back to this term infrastructure as code a little bit later as well, because, yeah, code as they define it isn't necessarily the way I would think about it. When we think about the main cloud providers, they all have essentially a tool, a mechanism for doing this. So Azure has the resource manager, AWS has CloudFormation, and Google has their deployment manager. I'm an Azure guy, so I'm going to spend most of my time talking about Azure. Most of the concepts I'm describing here are going to be applicable to the other clouds as well. So with Azure Resource Manager, the starting point really is an ARM template. Now, there was a talk earlier in this event about bicep, and I'll touch on bicep a little bit later. But initially, I'm going to focus just on ARM. So let's have a look at an ARM template. Now, that's quite scary at first glance. I mean, that's a full page of what looks like JSON. And all this code is really doing is creating a storage account. So let's break it down a little bit, zoom in a bit. This first section here, we're creating a parameter, we're defining a parameter, we're setting a default value. So in this case, it's a storage account type, and we're saying it's a standard LRS. The person who's authoring this template needs to know these values. They need to know that that's a valid option. They've been really kind. They've set a set of allowed values here. So if you're using this template, you can't get it wrong. That's awesome. But if Azure goes and adds another type of storage account, you're going to have to update these templates to set the new values in there. So that's a bit of a pain. But so far, this is OK. This is basically JSON. It's all good. This next parameter is where things start getting a bit weird. So it looks like JSON till we look at this section here. All of a sudden, that's not JSON. That's something else. We're getting these square parentheses, and we've got what looks like a method, maybe. That's not JSON, so that's something I need to learn. That's something new. And this is just the tip of the iceberg. Let's move on to actually creating the resources. And again, I'm just going to whiz through this a little bit because it's not really an ARM talk. Here we create the resource itself, and now we're referencing those values. So again, there's this syntax here. This is typically done in a file that doesn't necessarily have all the toolings that will tell you whether your syntax is correct or not. All of a sudden, what looked like JSON is now starting to look like something else, some kind of hybrid. And if your day job is to work with these things day in, day out, that might be fine. You'll get used to it, you'll learn it, you'll understand it. If you're a smallish development team who does some Azure resources as well, you come back to this kind of stuff after a few weeks away, you're going to struggle a little bit potentially. But once we've got these templates, we can use a number of mechanisms. I'm showing you the CLI here, but I can run AZ group deployment create, pass in that template, and it can get provision. And the nice thing now is this is automatable, if that's a word. Tools can do this for you because now everything is in that template, and that's great. You're not sitting there clicking a mouse. So, as I said, these cloud templates, they can be automated. They're great for that reason. They're declarative, so you define everything you want. Your end state is in that file, usually. And you tell the underlying engine, so Azure Resource Manager, for example, to go away and create it for you. You're not having to tell it to do stuff step by step. And of course, it's a lot easier now to provision multiple resources. So I can run that same template with a different set of parameters, and I've very quickly got another set of resources. And because these templates are referencing each other, the underlying engine can usually resolve the dependencies. It can figure out that you need to create this resource first because it's referenced by this later resource. And again, that's useful. So what are the challenges with this? Well, as we've already seen, it's very verbose. But the big one really is you need to learn a domain-specific language. And this is aside from learning the actual API of the cloud provider. Like, do I need an LRS storage account or a GRS storage account? That's a different problem. This is just learning the syntax. This syntax, DSL, is nearly always cloud provider specific. So you move from AWS to Azure, you need to relearn everything again. The underlying engine is usually closed source. That may or may not be a problem. So deal with some of these issues. A lot of people turn to a tool called Terraform. So Terraform is an open source tool created by HashiCorp. It's written in Go, the cloud native language of choice, till Rust kind of took over, I guess. They use their own markup language. But I guess a key difference between Terraform and ARM is Terraform is designed to be multi-cloud, multi-platform. So the theory is that to some extent, you can reuse the code, the syntax you learn across these different providers. So let's have a look at an example of creating a storage account using Terraform. And immediately you can see it's a lot terser. It's just a lot easier to read. I'm going to whiz through this quite quickly, but you can see here we're referencing variables. We're just dotting into them. This feels a little bit more natural to me. So what are the issues with Terraform? Well, yet again, it's another domain-specific language. Probably one of the bigger issues with tools like Terraform is it lags behind the cloud provider. So Terraform uses a concept of providers, which are built off the API that the cloud provider exposes. If a cloud provider releases a new feature, it could take days, probably optimistic, weeks, months, years, indefinite amount of time for Terraform to support that feature. And then another challenge, arguably maybe not a challenge, is state management. So Terraform maintains a state of your infrastructure in its own special state file. And you need to kind of look after that, really. And depending on how you do things, there's a chance you can have secrets in that state file as well. Again, that's not necessarily a strong con, but it's just something different. So far, I've shown you really, really simple examples, just the storage account. And we've seen huge ARM templates for that. Our infrastructure is quite complex. We have requirements for doing conditional logic. When we deploy to a staging environment or a test environment, we deploy slightly different resources. We might not geo-replicate the database because we don't need it in a test environment. We might want loops. We may provision a similar resource multiple times. And sometimes we need to deal with third parties. So we use, say, Auth0, for example, or Cloudflare. We don't have support for that in ARM templates. I do want to talk a little bit about some of these more complex scenarios in these templates, because this is probably the thing that really broke me, to be honest. So conditional logic isn't too bad, but again, it's this thing. So we've got here, got a parameter that basically says allowed values yes or no, and I'm defining my resources, and now I've got allowed values there, and then we've got this conditional element, and it says if that parameter equals yes, then you deploy that resource. If you don't, if it doesn't match, then you don't. Again, more of this weird syntax. Let's have a quick look at that in Terraform. So Terraform does this slightly differently. They essentially have a ternary expression, which is evaluating the value for count. If the count is 0, it doesn't deploy that resource. If the count is 1 or more, it will create multiple instances. This is probably slightly more understandable for a developer especially. And then loops, my absolute nemesis. So it's a bit of a contrived example here, but we're trying to create multiple web apps with a different name. And we have to do this concat myapp with the parameters and then this copy index function. And then we've got a copy block at the bottom there, and we're using the length of that purpose array. Seriously, what the hell? Honestly. As I said, I work with this stuff regularly, and that's fine. Before I moved to Aura, I was an independent consultant, and I was working with a client to create ARM templates, and they were using an app gateway. And if any of you have had the pleasure of opening an app gateway ARM template, it's thousands and thousands of lines. And then to try and do anything where you're looping, they were creating multiple websites, and they needed to have set up the routing for additional websites by defining them. It blew my brain trying to figure that out. But even if I could figure it out, how on earth was this team of 6 or 7 developers who spend most of the time writing full stack code come to this and understand it? And that was really, this is quite a while ago now. I think it's probably tail end of 2018 that I came across Pulumi, and I absolutely kind of fell in love with it. But we'll come onto that in a second. This is Terraform's example of doing the loops. A bit better, so here we've just got an array, and we just use the length for the count, and we index into it. So slightly more understandable, but same issue, really. What about third-party APIs? So Terraform, templating, you generally have to drop down into running some kind of script. It's not easy to test your script. Another annoyance you generally get is if you're using a third party's kind of tooling, your build machines or wherever that script is running needs to have those tools installed. And then for a team who isn't necessarily their day job, yet another language they have to learn, yet another language they're going to have to potentially make mistakes on. So we come back to this infrastructure as code. And to be fair, the definition did say machine-readable definition files. So that's great. But when I zoom in on that word code, it doesn't really sit well with me, because what we saw there wasn't really code. It was markdown with some code-like syntax shoehorned into it. And this is where I think the Pulumi folks first coined the term, although it's not that popular, infrastructure software. So what if we treated our infrastructure like we treat our software? And that's really where Pulumi comes in. So Pulumi is an open source tool that allows you to use modern general purpose programming languages to deploy and manage your infrastructure, in particular your cloud resources. It supports multiple platforms. It's a declarative platform. So when we look at the code, you will instinctively think it's imperative. It looks imperative, but it's not. It's declarative. Pulumi is actually free and open source, except for one component called the Pulumi console. That's the bit that is essentially their money maker, if you like. And we'll dive into a little bit later. So it supports multiple, I've written languages, arguably runtime. I saw a tweet yesterday saying Node.js is a runtime, not a language. Fair enough. So you can use TypeScript with Node.js, .NET Core, Python and Go were the original ones. And recently they added Java and then Pulumi YAML. Now, I'm not really going to talk too much about that, but it's quite interesting. One of the propositions of Pulumi, one of the areas that it saw quite a lot of growth was their Kubernetes provider, because you could use Pulumi to manage your Kubernetes, and therefore you didn't need to use YAML. Then they've gone and created a YAML provider, so you can now use, I think you can probably use YAML to manage Kubernetes YAML, so hey, whatever. Pulumi has a concept similar to Terraform. There's a shared history, shall we say, in the past there. We can happy to talk about that afterwards. They've got a concept of providers, and they've got a Pulumi registry where you can go and get these providers. So you can see they've got they'll have the main cloud providers, they've got Kubernetes. Essentially any platform that exposes a decent API can have a Pulumi provider created for it. You can create your own, you can submit your own to this registry as well. And I think as the time of this screenshot, there were 96 in this. Some are maintained by Pulumi, some are maintained by others as well. So how do I get started with Pulumi? So Pulumi is a CLI tool predominantly. And what it lets you do is bootstrap a project to get you started. So what I do is in the CLI, I can do Pulumi new Azure C#. So that's going to create me a new project based on C# and targeting Azure. So I fill in some variables here. The one that's probably new or maybe not so familiar is the stack. The stack there is essentially the environment, so production, development, etc. So in the time it's taken there, so in 3 seconds, it's created a project for me and tells me I can go and run Pulumi up. But what we'll do is we'll fire that up in VS Code and we'll take a look at what has Pulumi created for us. So this looks like a CS proj file there. This looks like a .NET project. And if you look at the CS proj, it is indeed a .NET project. Just a standard console app. This screenshot's a little bit old, so the package reference down here is a little bit out of date, but essentially it's referencing a NuGet package. But you can see it's an XC targeting .NET Core app. Standard stuff here. Let's have a look at the actual code. So it put some sample code in for me. And again, this is C# code, stuff I'm quite familiar with. So let's dive in a little bit deeper here. So we're creating a variable called resource group, and we're creating a new resource group instance. And then now we're creating a storage account. And what you can see here is I am referencing the name, that variable, and I'm dotting into the property of it. So I'm getting IntelliSense here. We'll see that in a second. I'm getting syntax checking. I've got the C# compiler telling me if I'm doing something stupid. So what do I do with the C# file now? So I come back to the CLI, and I can run Pulumi up. And what that's going to do is look at my code. It's going to compile it. It's going to make sure it builds. And then it's going to tell me what it's going to do. So it's telling me now it's going to create a resource group and a storage account. I've got a choice there. I went straight to yes. And now it's going to go ahead and create this. Now, this is real time, so I haven't edited this video or anything. So we're watching this provisioning in real time. Shouldn't take very long, although it feels longer while I'm standing up here talking. Of course, when you're dealing with cloud providers, most of you probably know, they're not deterministic. You can't be sure that if it takes 5 seconds once, it won't necessarily take 5 seconds a second time. It can vary. This one won't take very long, but I didn't mention, I have one demo that's almost certainly going to fail today, but these videos shouldn't fail. So if it goes horribly wrong, you know. So in 33 seconds there, it's gone and created my resource group and my storage account, and it's even, I asked it to give me back the details of the storage account, the connection string to the storage account, and you can see that there. So yeah, there is some secrets in there, but not to worry. There's also this link at the bottom to app.pulumi.com. So let's, sorry, actually, before we do that, let's change something. So that's a resource provision, but really, it's what happens on day 2, if you like, that matters. How does that work? So come back to the storage account, and now I'm going to add some tags to this. I should pretend I'm typing this, shouldn't I? Slick. But you notice here that I've got IntelliSense. I'm just typing some code. So I've added some tags. And what I can do now is come back to the command line again. I run Pulumi up again. And this time, Pulumi is going to look at what it thinks I've currently got provisioned versus what is provisioned. And it's going to show me what it's going to do additional, what's different. So we let that run for a second, and you can see that it's saying that I'm just going to update 1 resource and 2 are unchanged. And here I can go into the details. So I can dive into the details, and it shows me that, yes, I'm going to update the tags there. So then I can go ahead and say yes to that, and then in a few seconds, it should have updated that. So it's not touching the existing resource, not going to delete them. It's just going to add the additional. So again, those of you familiar with Terraform, this is all familiar stuff. And there we are, 11 seconds, we're done. So now we can talk about this link. So this link takes you to the Pulumi console. Told you I was out of practice. Let's have a look at the actual resources, because so far you haven't seen anything. So if I go into my Azure portal, I can see there's something called a resource group, and I've got a storage account. Now, the first thing that will probably strike you here is what these characters are in the name. They weren't in the code. So by default, Pulumi will append some alphanumeric characters to make the names of your resources unique, so you won't necessarily get naming conflicts. This is their recommended way of doing things. Now, of course, we know a lot of enterprises, a lot of companies in general, I guess, have naming conventions. They want your resource to be named in a particular way. You can override this behavior. If you can make this behavior work with your naming syntax, I would recommend doing that. Of course, some resources do have limitations, storage account being one of the main culprits for this, with limited number of characters you can use, and certain characters are not allowed either. So I'm done, I'm finished, and now I can just do Pulumi destroy. And again, even some of the keywords you're familiar with if you're a Terraform person. So this will now just go ahead and delete all of the resources that it provisioned. Now, there's a little bit of a gotcha here you have to be careful with. So because Pulumi provisioned the resource group, if I then went into Portal and added some additional things into that resource group that Pulumi didn't know about, and then did this, Pulumi is going to delete the resource group. By default, when you delete a resource group, any of the resources within it will get deleted as well. So you do need to be a little bit careful. This video, I did edit slightly. It took 55 seconds to delete that, and it's all gone. That's it. I'm not paying for it anymore. Now let's have a look at the console. So this is the bit you pay for. Well, depending on the pricing tier you use, we'll come on to that second. So here I'm in the Pulumi console, and I'm looking at my project, which is this demo, and I can see my stack up there. I can see my stack. And in fact, if I run this through, I can see some of the variables I've used, so you can see the details of my project. Here's a really nice bit. I go to my activity, I can see everything that happened to my infrastructure, step by step. And I can dive into that and see the outputs, see the diffs, what was created when it was run. So I've got really nice view of why my infrastructure in a state it is at the moment. And you can see this through here. Additionally, I'm not sure if it shows it on there, but it will link back to your GitHub commits as well. So where is Pulumi really useful? I would say to any team, really, if you're doing infrastructure, Pulumi's head and shoulders better than the other options, in my opinion. I don't work for Pulumi, by the way, as you know, this is entirely independent. Where I think it really excels is if you're a small, moderate-sized team who doesn't necessarily have Azure experts. Even Aura, our engineering team is around, I don't want to get this wrong now, but I would say around 50 odd, maybe 40. And most of them are engineers who don't necessarily spend a huge amount of time with Azure. But we want them to be empowered to manage the infrastructure they're using for their code. So if you know .NET already, then there's a good chance you can pick up this stuff a lot easier than you would those ARM templates. Now we're going to be using familiar tools and workflows for managing our infrastructure. So this is not going to be something that's quite jarring, quite different to a developer. And that console is really quite powerful because it lets everyone see what the current view is, what the audit trail is. When it comes to third-party APIs, I talked about this with the templating options, the fact that you've got a drop-down to run scripts. Well, Pulumi has these providers, and that's great. You can use a provider. But if there isn't a provider, you can use any of the .NET SDKs they have, if you're using .NET, of course. And you can pass variables from Pulumi into the SDK. You used to have a bunch of slides on this topic because there's a feature in Azure called Azure Storage Websites, and it didn't support the ability to enable the websites feature through the ARM APIs. So there was no real way of doing it, and when I was using Pulumi, we spun up the storage account with Pulumi and then used the .NET SDK for storage to actually enable that feature, passing in the connection details for the storage account to the SDK within the same code. There's an example of it on my blog post. It's quite old now. That feature is now implemented and fully supported anyway, so you don't need to do it anymore, which is why I took it out. But it's just an example of where you have the power of the C# ecosystem at your hands potentially as well. I talked about the workflow. Well, you can integrate Pulumi into your GitHub process. So then you can submit a pull request to make a change, and you can see what the infrastructure is going to look like when it changes. You can approve it, and you can have it applied. And we'll have a look at this in a demo. You might have a bunch of existing resources. We certainly do. And how do we work with Pulumi? What's the options here? It's quite flexible, actually. You can decide just to coexist alongside. So Pulumi doesn't need to know about those resources. The resource group thing I mentioned is a bit of a gotcha you're going to need to be careful of there. So don't create the resource group in Pulumi. Let it just reference it. But you can start creating additional resources using Pulumi and keep your templates and eventually move them over. There is a way of writing the actual code for it. So let's say I've got a website, a web app that I want to bring into Pulumi, but I don't want to destroy it or recreate it. I can tell Pulumi, I can write the code for the website in the Pulumi code, and then tell Pulumi to adopt it. Essentially, it adopts the existing resource, and then it becomes kind of under Pulumi's control, if you like. Of course, you always have the option of just throwing everything away and writing it in Pulumi. You can also import existing resources using the CLI. So you can reference a specific kind of URN for a resource, and Pulumi will spit out the Pulumi code for that resource. That's really good if you just want to have a sample code, for example. But you have to do that per resource, so it's not necessarily that feasible for a large deployment. And similarly, they have, it's on their website actually, they've got a page where you can paste in an ARM template, and it will spit out the Pulumi equivalent in all of the different Pulumi languages as well. And again, that's quite cool, but it works with fairly basic templates. If you get anything too complex, it doesn't really work. And to be fair, that's really understandable because we use a lot of linked templates, for example, or we do loops in our templates. But of course, when the end result of that loop is 2 instances of a resource, Pulumi is not going to know that that originated or that should originate from a loop. So of course, there's that limitation there. Fairly recent addition is this automation API. So far, you saw me using Pulumi, and I was running the CLI tool. And that's great, and that will work for a lot of use cases. But what's becoming quite popular is teams wanting to build essentially an engineering platform for their engineers to use. And Pulumi has an API where you can use Pulumi from within your own code. So now the prospect of building a portal of your own portal, please don't replicate the Azure portal. This is more for standardized building blocks, for example, standardized deployments. We don't do this. We're probably not going to do this for a little while. But a good example where we want to use this kind of concept is when we deploy a SQL database, we want to make sure the database server has TDE on. We want to have long-term backups enabled. We want to have the, forgetting the name now, the Cloud Defender has gone through so many iterations. We want all of those features enabled every time somebody deploys a database. We do not want anyone to deploy a database without those things. We can standardize that into our resource that has all of those pre-built in. And you can do that without the automation API, by the way. You can do that actually as part of your definition, your templates. So what are the kind of pros of Pulumi? This is obviously going to be a very biased list given how much of a proponent I am. But you're using languages you're familiar with. So this is a lot easier to adopt for teams who are full of engineers. Generally speaking, you're going to have more engineers in a team than you're going to have cloud architects or DevOps people. As I said, you get the power of modern languages, but also third-party SDKs, I'm missing the party there, to achieve most things within the code itself. I think it's actually quite easy to get started. And it's free and open source. As I said, other than that console, go and use it for free entirely in your enterprise if you want. There's some, you can't use the console, but other than that, you can do everything else yourself. And as I said, with this automation API, you can provision resources from your own code. This may be a talk in future, I think, because it's quite a big topic in itself. So pricing, kind of spoiled you already by saying it was free. So as an individual, for example, you can use their console as well, and you can do what I've been using here for several years now, actually. So any cloud, any language, essentially one person, and then you get all of the things, unlimited deployment, state and secrets. We'll move on to the kind of paid tiers. They changed this fairly recently, but it's probably been like 6 months now, maybe even longer. The team pricing tier is now based on the number of resources you're managing. So you get essentially 150,000 credits, and those equate to roughly, I think I'm right in saying, about 200 resources a month. So you can manage about 200 resources a month and have all of the others, so 15 members, et cetera, for free. And then you start paying per resource you manage. So be honest, I wasn't a big fan of the pricing here, but then their previous pricing tiers had quite big jumps as well, and I wasn't a big fan of that either. So you can't please me either way, I guess. I've got to say, and we'll see, maybe we've seen the code, that Pulumi lets you manage your secrets as well in that console. So when we put state and secrets in the Pulumi config, it's actually encrypted and it's stored and managed by Pulumi, but you are free to use your own provider. So actually in Aura, for our deployments, we use Key Vault, we use Azure Key Vault for our secrets. So what are some of the challenges with this? Pulumi has fewer platforms supported than Terraform. Now, of course, that's very subjective. If the platforms you want to use are supported, awesome. It's like the Apple App Store having X number of apps more than Android or vice versa. If they're not apps you care about, who cares? This one is a bit unfair to put it in this section, but maybe I was trying to balance things out. I touched on this earlier, but you still need to learn the cloud provider's resource APIs. You need to know what the storage account means and what geo-replication means and what the limitations of that are. That doesn't go away with Pulumi. If you're a cloud architect watching this maybe online, you're thinking, oh, this will do me out of a job. No, because that should be your job, helping your team figure out what resources to use and how to stitch them together. Some of the errors you get with Pulumi aren't necessarily apparent until you run Pulumi up. Again, a bit harsh to put this as a Pulumi challenge. It's not Pulumi's fault. Ultimately, it means that the API, the provider's API, doesn't necessarily expose the right validation logic through its, I presume they're using things like OpenAPI, and it doesn't expose that. So until Pulumi tries to invoke the resource, then it gets an error because you didn't supply a mandatory value or something. And it's possible to get Pulumi into a bit of a bad state. So Pulumi does have this concept of state similar to Terraform. And essentially what's happening when you do Pulumi up is Pulumi is taking your code that you've written, turning it into a resource graph. So wherever the language is, turning it into a resource graph, and then doing the CRUD operations on the underlying APIs. Now, of course, if it tells Azure to go and create me a database, and that's taking 2 or 3 minutes, and I hit Control-C and break out of it, Pulumi is going to say, I have no idea what's happened now. Your problem. It's actually quite easy to fix. It does tell you not to do that, but when you're first iterating on this, you'll do this a lot. I did it a lot. And it's good fun trying to get it back because it really helps you understand how this stuff works, and that's, I think, is always really valuable, really important. Just want to kind of compare some other options because most cloud providers have an SDK. So there's a .NET SDK for Azure, so why don't you use that? Most of these SDKs, they abstract essentially REST calls into code. They're often even generated from the REST APIs. They're often imperative, so you have to essentially do the provisioning step by step. They're not necessarily idempotent, so it could be that you run the same code twice and you get 2 instances of the resource when you didn't intend to. Probably the biggest issue with them is they don't let you reason about your current state versus your future state. So you saw in the examples there, Pulumi told me that I've got these resources and I'm going to make this specific change. Well, with the SDKs, you generally can't do that because you're just telling them provision this, provision that, delete this, patch this resource. There's another class of tools out there called, I guess, generally called transpilers. And these have been growing in popularity since Pulumi's become popular. AWS has the CDK, and I believe it takes a general purpose programming language, but it spits out the templates behind the scenes, and those templates get executed. Farmer's an open source project, really popular. F# for generating ARM templates. And then Terraform recently introduced their CDK. Say recently, it's probably been a year. And again, it does a similar thing. It generates TF files from general purpose languages. So in some ways, it's a validation of what Pulumi have been doing. That these other, well, to be fair, Farmer's been around before that, but yeah. And I said I was going to come back to bicep. So for those who aren't familiar with bicep, bicep is a domain-specific language from Microsoft for essentially generating Azure resources. It's a replacement for ARM templates. It's a massive improvement over ARM, but it still has a lot of the limitations that ARM has in terms of its scoped to only Azure resources, for example. Now, if you're comfortable and you only ever use Azure resources and you're currently on ARM, then bicep's probably a no-brainer for you. Or you're starting out and you don't need to expand beyond Azure, bicep's probably a no-brainer for you. I had some demos, and I think my demo slide's missing, because this is my wrap-up slide. Yeah, I don't know what's happened to my demo slide, but let's, before I wrap up, let's jump across some demos. Otherwise, I'm finishing very early. What I'm going to do is I'm going to run Pulumi up, and then I'll show you some code, and then we'll kind of do what you've seen a little bit example of in the slides, but in real life. And this is where it probably all starts going horribly wrong as well. So I've aliased Pulumi to P because I'm lazy, and I'm going to run Pulumi up, and I'm just going to cheat, and I'm going to say, yes, just, oh, okay, this terminal doesn't have, I'm going to have to type it out now. It wouldn't be a talk without some demo fails, right? Cool. I'm going to let that spin away, and let's jump across to VS Code. Hopefully that's all. Well, actually, it's quite big. Let's make that a bit smaller. So the example I showed you was reasonably non-trivial. Sorry, it was really trivial, just a storage account. So let's look at something slightly more complicated, but not super complex. So I've got a resource group. Again, standard stuff in Azure. You always have a resource group. We're creating a storage account here. Creating an app service plan. So we're going to provision a web app. Creating a storage account. We're creating some blob containers, because what we're going to do is we're going to host a static page for our web app. We are creating the blob. We're getting some a URL to upload the blob contents. I'm provisioning a SQL Server here, although we're not actually using it in this demo. I just wanted to show you that you can. And for example, here there's a Pulumi package called random, and it will generate random things for you. And I'm using it to randomly generate a SQL admin password for my SQL Server. Creating a SQL Server here. Creating a database, and you can see all along so for example, the server name, it's just dot. It's I can come in here and get IntelliSense. I get help. So let's just undo that. Here we are creating the web app, and now we are going to use the connection string. We're going to create a connection string in the web app for that database that we're creating. So here, if you notice, I'm not defining the names of any of the resources, so they're going to have those random names. So how do I know the URL of the database? I don't. Pulumi is going to manage that for me. And because I'm referencing the variables everywhere, I don't need to know the names because it's just dot name. And then finally, I will ask Pulumi to spit out the name of the URL, and then there's this apply code, and this may look a bit weird. So if you think about the way Pulumi works, is, as I said, it's declarative, but also it's essentially doing an async to an API. But I've got variables here. I'm referencing a variable, so what on earth is the value of that variable? Like if I'm deploying a SQL Server, what's the URL of it? I don't know at the time I'm writing this code. So it uses essentially something similar to a promise. So you'll see a lot of input of type T and output of type T. And sometimes that can be a bit of a pitfall when you want to say, well, I just want the value. I just want to output the value. Because if you just output the property that you think is a string, when it spits it out, it'll be a generic type of T. It won't tell you the value. So this apply with this lambda is a way of essentially taking the actual value at the time when it's available and then putting it through here. So I'm taking the domain name and putting it through and putting the HTTPS at the start. So it creates a URL for me. So hopefully I've talked enough that it's finished. Oh, it hasn't finished yet. Okay. I want to make that slightly smaller because that's really big. Oh, that's good timing. And yeah, there we are. It's finished. And I should be able to come across here and click on that. And it's a tense moment as we wait. And there we are. So from scratch, we spun up a web app, and we deployed some static code. Now, again, obviously, it's a demo example, but it's pretty standard. So that's great. And now, what if I want to make a change? So I've got a single storage account. What if I want another storage account? So let's do this the proper way. So if I come over to my GitHub repo here, I've got a branch that I've already created. So I should be able to create a pull request. And we should be able to see the diff. So I've got this one here. And what we can see here is I've just added another storage account. So yeah, it's quite visible there. Got another storage account here. So let's create a pull request. You're all reviewing the pull request. Thumbs up? Happy? Awesome. Let's create a pull request. And what we'll see is that pull request is now running, and it's running Pulumi preview. So we'll take a few seconds to run. That was quick. Not still running, that's an old run, I think. Let's come back to, let's just go back. This is now where you're at the mercy of GitHub Actions. And later I'm at the mercy of Cloudflare, so what could possibly go wrong? Well, to be fair, Cloudflare have been awesome most of the time, so let's not pick on them. Eventually, this will show me in my pull request the changes it's going to make. So as a colleague who's doing pull request reviews, like we have as standard policy in Aura, we don't commit anything without a pull request review, we can see that it's now going to replace the blob, and it's going to create another storage account. I'm not sure why it's doing that top one, but what I can do is go ahead and merge that, and I've got a GitHub action that will actually run Pulumi up. Now, I'm not going to do that because I want to run the other demo, the one that's probably going to fail, but it's still fun to have a failing demo, I guess. So I won't run that. I won't merge that, but I can quickly show you the action. So that was the preview action. So this is the update action. And let's have a look at the YAML. Can't get away from the YAML. So in this example, it's really trivially straightforward. So I'm using GitHub environments. And sorry, I'm not using GitHub. I'm just using GitHub secrets. So I'm grabbing the Pulumi access token for the API. And it's basically just running it's the Pulumi GitHub action. And it's just running the up command there against my stack name. It's really straightforward. What I need to do here is actually probably want to destroy what I've got at the moment, because the other stuff is slightly different. So let me do that. Never do what I've just done there, which is -- yes, because it won't ask you to confirm what you're about to delete. We'll just go and do it. So that's going to go in, start deleting. So what you saw with that example I did there was it had Azure weird random characters.azurewebsites.net. That's not really what I want. I want a proper domain name on there. So I have another branch. So let me change my branches. I'm going to do it from here because it's a bit easier. Let's branch to here. This is almost the same code, but I've just changed it slightly. I've got rid of the database and stuff like that. It's not really super relevant. But what I've got now, if I come over to the CS proj, is I've got Pulumi.Cloudflare as an additional provider in here. So what I want to do, I want Pulumi to go and create some Cloudflare records for me. If I show you my config file, I've got an API token for Cloudflare. And you notice this says secure, so that's fine. Screenshot that all you want. That's no use to you. That's encrypted per stack. So even if I copy this config and create another stack, the values are not useful to anybody. And Pulumi is quite good. When you try and set a value that looks like a token, it will say to you, this looks like a token, are you sure? And it forces you to put a -- secret or -- plain text, I think, and after it. Otherwise, the rest of the stuff is fairly standard stuff, just Azure. So the client ID, client secret is the service principal that's talking to Azure. So let's have a look at this code quickly. And sorry, let's have a look at this code here. And as I said, it's similar to what I've done, but now what I'm doing is I'm deploying that web app as before, but now I'm creating a DNS record. So in Azure, if you want to bind a custom domain, you have two choices. You either create a CNAME record that maps to it, and Azure will validate that CNAME record, or you can use, the issue with the CNAME record is that you have to point the CNAME to the new resource, then Azure has to validate it, then you approve it, and obviously there's some downtime in that point. So the alternative mechanism is to use this verification domains. So you create a TXT record instead with a particular value that Azure gives you. And then once that approves, then you can bind the CNAME, and you can bind the domain name, and then you can point the CNAME over. So that's what I'm doing here. I'm creating a TXT record for that validation domain. Then I'm creating the actual DNS record. And incidentally, here is one of the options you have for forcing a dependency. So Pulumi will do a very good job of realizing what the dependency graph is, again, because you're you're referencing the variables, right? It's actually really straightforward. But sometimes you really want to force an order, and you can do that with this depends on property. And this is where things start getting slightly horribly wrong because it's DNS. So when I've run this numerous times, it's worked 20% of the time. The other time, the DNS propagation hasn't happened quick enough. I added this line in, and this is just a way of, I guess, also showing you that you can get an existing resource and reference it in the rest of your infrastructure. So I'm getting that DNS record by the ID. It's just off the screen, but this DNS record here, I'm asking Pulumi to go and get me the DNS record. And the theory was that it would take a few milliseconds, a few hundred milliseconds to get that record, and that will be enough to propagate. The key problematic step really is here. So now we ask Azure to do a binding of the custom name. We're passing in all the properties, so we've got the DNS record name and everything else. So if it works, we'll have a custom name. If it doesn't, this is a bit of an issue, but it's easy to work around, but I'm still not happy with it. So what I can do now is I should be on the other branch now. So if I now do Pulumi, should we just go up? Yes. Yeah, what the hell? We've got 10 minutes left, we may as well YOLO it. So it's going to spin up the similar set of resources, but now a couple of additional things. Hopefully it'll be a bit quicker because I'm not doing the database and various other things. You can also see by the number of updates. This is the equivalent of console app 97. I've got console app 101 so far on this demo. I suppose I could have cheated here, and I'm kind of cheating, which if it works, I will show you the slight smoke and mirrors I've used. Well, I'll tell you now while we're waiting. If you have a custom name, you're going to be typically going to have a TLS custom certificate, right? Because Azure's certificate's not going to match. Binding certificates, or creating a new certificate and getting it bound takes quite a long time. So one of the beauties of Cloudflare is you can let Cloudflare proxy the TLS. So Cloudflare will put the TLS on there, and then the backend call will still be over TLS, but it won't be under the same thing. So it actually just works if the binding works. It's a tense moment. I should get people to put their hands up if they think it's going to work. So now we're creating the DNS records and we're creating the custom binding. That was quite quick, so let's see. It worked. Yay. Thank you. I say that, but where is my custom domain? I've got a bug in my code, I think. Let's have a look at what it should be, because that's the old domain name. Let me check what I set it to. So at the top somewhere. Okay, so it should be that. So let's have a look. We may have applause. The applause may have been a bit premature. So it's Pulumi. Actually, let's do that in a new tab, so it's not caching. So Pulumi demo. Was it -3 or that? I think it was -3. Tensions building. Hasn't failed straight away. Is that a good sign? Yes. Yeah, that was some emoji that clearly I didn't think about the encoding. You can tell I'm a back-end developer, can't you? That styling. Cool. I think that was all the demos. If you want me to, I can merge that pull request, and we can. Oh, that's going to be horrible. Let's not do that. Just asking for trouble now. Let's skip back to the slides quickly. Kind of ruined the moment on that slide, but. The way I see this is it's a bit of an evolution of your cloud architecture. So when you start off, you're kind of dealing with portals. And I have to admit, I'm a big fan of portals. It's my first port of call, excuse the slight pun there. And arguably, well, when you kind of evolve beyond that, you'll start using the templating, and that's generally a very good step forwards, right? You don't want to be doing the stuff in the portal. If you stop there, that's fine. That's perfectly fine. I'm not here to say everyone should be Pluming all the things. Controversially, maybe, I think Terraform is a step beyond. For a long time, when I heard about Terraform, I was, well, we're pure Azure. Why would I bother with Terraform? When you look at the Terraform and the Azure template side by side, there's an argument to be made there that the Terraform syntax is so much better. But really, when we move to the next level is Pulumi. We're now doing infrastructure software. We're dealing with workflows and tools and stuff that we are familiar with as developers, and as a cloud architect, I want the teams who run their software to be able to manage their infrastructure as well. With boundaries, there's a ton of stuff I haven't covered with Pulumi around testing, policies, bunch of other stuff. Happy to chat to people afterwards. If you want to learn more, Pulumi has a bunch of examples on their GitHub page. Different cloud providers, different languages. Oops, let me go back one. Their Slack, I haven't been on there for a little while, but their Slack is awesome. The Pulumi folks are just fantastic. A huge shout out to the Pulumi folks. They're so responsive, so engaging and helping. And for some reason, I left a link to my blog. I haven't blogged for ages, so don't even bother. There's probably like cobwebs and stuff on there. So all that's left for me to say is, of course, yes, we're hiring. Huge thank you to folks at Aura for letting me do this. This is work time. That's technically a public holiday in New Zealand today, and we have a bunch of roles open. It's an awesome place to work. If you want to fancy moving across the ditch, please come and have a chat with me. Otherwise, say thank you. I'll take any questions. Now I'm here for the rest of the day as well. So got about 5 minutes, I think, maybe less. I've got 2 minutes, so maybe take one question, and then I'm happy to pack up to the next speaker, and then we can take questions after that. Yep.
In your demo, you mentioned that when there's a deployment running, you wouldn't want to merge your pull requests. Was there any concurrent lock problems?
So there's a fairly recent feature. I think it's still in preview, where it will lock the preview. So what you see in the preview is what will be executed, and if something's drifted in between that stage, then it won't execute the up command, which is exactly what you want in that situation. If you imagine multiple people are making changes, you want to know that the person who's approving that PR, if the PR is going to merge and then run the up command, you want it to run what you thought was the state at the time when you approved that PR. There's a chance somebody could have made a change in between that. So that's where this concept, essentially, it locks it to that preview. So if it doesn't match that preview, then it won't execute. So yeah, that's a safeguard for that, exactly that cause. Yeah.
That's awesome, thank you.
I think we can call time there then, I think. Again, thank you so much. Enjoy what